Hello, everyone. Welcome to Sleep Space. Tonight, we will talk about one of the most profound and mysterious questions ever asked. What is reality? It's a question that lies at the heart of science, philosophy, and even personal experience. Is reality the physical world around us? Is it something deeper, more hidden, perhaps even simulated or constructed by consciousness itself? As you listen, let yourself drift into this vast, curious landscape of thought and discovery. And before we begin, I'd love to know, where are you listening from tonight? And what time is it for you? Whether it's midnight in Tokyo or sunset in California, I'm glad you're here. Let's begin. The word reality is so familiar that we rarely stop to think about what it actually means. We walk through the world assuming it's real, that there's an external environment made up of matter, space, and time, and that we perceive it through our senses. But when we take a closer look, scientifically, philosophically, even psychologically, this assumption begins to blur. Let's start with the basics. In classical physics, reality is a material universe governed by deterministic laws. The universe is a kind of machine, like a giant clockwork that ticks forward in predictable ways. Everything, planets, atoms, even human behavior, can, in theory, be explained by the interactions of particles and the forces acting upon them. This Newtonian view dominated science for centuries. It gave us a stable, objective picture of reality. Things exist independently of us, and we discover them through observation. But in the 20th century, this picture was shattered. The rise of quantum mechanics fundamentally changed how we understand the nature of things. At the quantum level, particles don't behave like solid objects, they behave like probabilities. An electron isn't a tiny ball orbiting an atom's nucleus. It's more like a cloud of potential positions, described by something called a wave function. It doesn't exist in a specific place until it is measured or observed. This leads us to a very strange idea. Observation affects reality. The famous double-slit experiment demonstrates this perfectly. When particles are not observed, they seem to pass through both slits at once, interfering like waves. But when we measure which slit they go through, the interference pattern disappears. They behave like particles. Somehow the act of measuring changes what is real. This has led many to ask, does reality depend on consciousness? Is the observer somehow essential to the existence of things? These questions are not fringe. They are taken seriously by physicists and philosophers alike. One interpretation, called the Copenhagen interpretation, suggests that the wave function collapses into a definite state when observed. But what does that mean? If observation brings reality into being, is reality truly independent of us? Another interpretation, called the many worlds interpretation, offers a different take. Instead of the wave function collapsing into one outcome, it suggests that all possible outcomes actually happen, but in separate, branching universes. Every time a decision is made, every time a particle has multiple possibilities, the universe splits. This means there could be infinite versions of reality, each one as real as the next, but inaccessible to us. Now let's turn to relativity. Einstein's theory of relativity brought its own revolution to our understanding of reality. Space and time, which we had assumed were separate and absolute, are in fact woven together into a four-dimensional fabric called space-time. Events that appear simultaneous from one point of view may not be simultaneous from another. There is no universal now. This leads to strange but undeniable consequences. Time can stretch or contract depending on how fast you move or how close you are to a gravitational field. Two people moving at different speeds will literally experience time differently. This isn't just theory, it's been confirmed by experiments with atomic clocks and GPS satellites. So, what is the present moment? If time is relative and every observer has their own version of now, does the idea of a shared present even make sense? The block universe model, which arises from relativity, proposes that all points in time, past, present, and future, exist equally. Time doesn't flow, it's all there, like the pages of a book. We only perceive it as flowing because of our consciousness moving through it. This suggests that everything that has ever happened or will happen still exists in some form. Your childhood, your future old age. They might all still be real, just not from your current point of view. This starts to dissolve the neat boundaries we place between experience and reality. Perhaps reality is not just a backdrop for our lives, but something inseparable from the way we experience it. This brings us to the question of perception. Your brain doesn't see reality directly, it interprets signals from your senses, light hitting your eyes, sound waves vibrating your ears, pressure on your skin, and constructs a model of the world. What you experience as red or loud or smooth is not something that exists out there in the world, but a mental representation. Even the idea of solid objects is misleading. Atoms are mostly empty space. The sensation of solidity comes from electromagnetic forces repelling each other. So, if all our experience is filtered through perception, how can we be sure of anything outside it? This is an ancient philosophical question. Descartes famously doubted everything except the fact that he was doubting. I think, therefore I am, but even that may not go far enough. Neuroscience has shown how easily our perception can be fooled by optical illusions, hallucinations, or brain injury. People with certain neurological conditions may believe a limb that's gone still exists, or fail to recognize their own reflection. If perception is this unreliable, what can we say about reality? One school of thought, called idealism, suggests that consciousness itself is the fundamental substance of reality. Rather than consciousness arising from matter, matter might arise from consciousness. This is not merely mysticism. Philosophers like George Berkeley, and more recently, scientists like Donald Hoffman, have proposed that space, time, and objects are just useful interfaces evolved by conscious agents to interact with a deeper, unknowable reality. Much like icons on a computer screen don't show you the electrical circuits underneath, our perceptions may be like symbols, hiding the true structure of the universe from view. This aligns in a curious way with simulation theory. If our perceptions are simply a user interface, then perhaps they are being rendered by a computer or by some higher intelligence. The idea that reality might be a simulation is not just science fiction. Physicist Nick Bostrom proposed that if any advanced civilization has the ability to simulate conscious beings and chooses to do so, the number of simulated beings would vastly outnumber real ones. Statistically, we are more likely to be simulated than not. While controversial, this theory is consistent with much of what we already believe about information, computation, and the limits of physical systems. So, what are we left with? Quantum mechanics suggests reality is probabilistic and observer dependent. Relativity shows us that time is not fixed and the present is not absolute. Neuroscience reveals that what we experience is a model, not the thing itself. Philosophy questions whether the material world exists at all, or whether consciousness is the only certainty. And physics increasingly hints that information may be the most fundamental building block, more basic than matter, energy, or even space-time. This convergence across fields leads to a radical idea. Reality might not be a thing, but a process. Not a static world we live in, but an ongoing interaction between consciousness, perception, information, and mathematical structure. The real might not be out there waiting to be discovered, but something co-created with each moment of experience. And still, despite everything we've explored, reality remains elusive. Every answer opens new questions. What is the difference between what is real and what is imagined? If dreams and waking life are both experiences, what makes one more real than the other? And if reality is dependent on perception, then is it ever possible to experience it in its raw, unfiltered form? You're listening to this now, perhaps in the stillness of night, surrounded by the quiet hum of your environment. But even that, this very moment, might be constructed. The sound of my voice, the feeling of time passing, your sense of being a self experiencing this, all of it is part of the reality you inhabit. But is it the reality, or just a reality? To go further into the question, what is reality, we need to explore the role of information itself. In modern physics and computer science, there's a growing view that reality might not be made of matter or energy, but of information. This shift began as scientists explored the limits of computation, black holes, and quantum entanglement, and started realizing that what we call physical objects might be emergent phenomena arising from fundamental bits of information. Let's begin with a simple but profound insight from the field of digital physics. Anything that can be described in terms of ones and zeros can be simulated. That means every process, every object, every event in the universe, if it has a pattern, can potentially be described as an informational structure. This isn't just theoretical. Every particle interaction, every field, every movement can be modeled by mathematical equations. If nature obeys these laws so perfectly that a machine can replicate them, is there any meaningful distinction between a real world and a perfectly simulated one? The idea that the universe might be made of information was famously expressed by physicist John Archibald Wheeler in the phrase "it from bit." What he meant was that every particle, field, or force arises from bits of information. Rather than information being something we extract from reality, it might be what reality is. This turns our traditional view inside out. Instead of a world made of stuff, with information as a property of that stuff, perhaps the stuff is simply the shape that information takes when it's observed. To make this concrete, think about how a digital photograph works. What you see, a detailed image of a person, a landscape, or a moment, is stored in a series of binary numbers. It's not the image itself that exists, but a pattern of information interpreted by software and projected onto a screen. If the file is deleted, the image vanishes, but the potential for its existence could remain in a backup or a code fragment. The image is not a physical thing, but a virtual structure instantiated through information. Now take that metaphor and apply it to everything. Your body, your thoughts, the stars overhead. Could all of it be structured information? In black hole physics, information plays a pivotal role. When something falls into a black hole, does the information about that object disappear forever? According to classical physics, it would. But that creates a paradox. If information is truly lost, It would violate the laws of quantum mechanics, which insist that information must be preserved. This led to a decades-long debate known as the black hole information paradox. Eventually, a new understanding emerged. Information is not destroyed, but somehow encoded on the event horizon of the black hole, a kind of cosmic hard drive, storing the data about everything that's fallen in. This insight led to the holographic principle. The holographic principle is one of the most mind-bending concepts in modern physics. It suggests that everything we experience in 3 dimensions may be encoded on a 2-dimensional surface at the edge of the universe. Just as a hologram can project a 3-dimensional image from a 2-dimensional film, our reality may be a projection of data encoded on a distant boundary. According to this model, your entire experience of depth, distance, and volume could be emergent, like an illusion generated by underlying informational patterns. If this sounds abstract, think about how a video game works. The character moves through a rich 3-dimensional world, but behind the scenes, everything is just data processed by a machine. The world looks deep and textured, but it's all numbers. What if our universe operates the same way? What if space and time themselves are emergent properties, constructed from a more fundamental, informational substrate? Some researchers believe that space-time might not be smooth and continuous, but quantized like pixels on a screen. If true, it would mean that reality has a smallest possible unit of space and time, Planck length and Planck time. Below these scales, the very concepts of distance and duration may lose their meaning. This pushes us to ask, if the fabric of the universe is pixelated, what is it made of, and what renders it? One potential answer comes from quantum gravity and loop quantum gravity models. These suggest that space itself may arise from loops of quantum information woven into a kind of cosmic network. Reality, at its deepest level, could be a vast web of relationships, not between things, but between possibilities. And your experience of reality might emerge from how your consciousness interacts with this network of potentials. Now let's shift from physics to neuroscience. The brain is an organ built to interpret information. It's not just passively receiving signals, it's constantly predicting what's about to happen next. This idea is known as predictive processing. Your brain is a kind of simulation engine, modeling the world in real time based on patterns it's learned. It fills in gaps, anticipates outcomes, and even invents details where the data is unclear. In fact, your perception of reality may be more like a controlled hallucination than a direct reading of the external world. Consider optical illusions. 2 lines of equal length can appear drastically different if they're surrounded by certain shapes. A grey square can look white in one context and black in another. Your brain isn't wrong, it's using context to interpret ambiguous signals. But this shows how malleable reality is. You don't perceive the world as it is, you perceive the best guess your brain can make based on limited, noisy data. This becomes even more fascinating when we look at conditions like synesthesia, where people experience cross-wired senses. They might hear colours or taste sounds, or consider phantom limb syndrome, where an amputee still feels sensations in a limb that no longer exists. In dreams, we experience entire worlds that feel real while we're inside them, yet they're generated entirely from within. If your brain can create convincing realities while you sleep, and if your waking perception is a modeled prediction, then what does that say about the boundary between real and imagined? Is a dream less real just because it's not shared? Or is it simply a different mode of experiencing information? This leads us to the topic of consciousness. What role does it play in shaping reality? Is consciousness an emergent property of physical systems, an epiphenomenon of complex brain activity, or is it more fundamental, perhaps even primary? Some scientists propose that consciousness is not something that arises from matter, but something that gives rise to matter. This view, called panpsychism, suggests that consciousness pervades the universe at every level. Even subatomic particles might possess a kind of proto-awareness. Others go further, suggesting that consciousness and information are two sides of the same coin. Integrated information theory, for example, proposes that consciousness arises from the integration of information within a system. The more integrated and irreducible the informational structure, the more conscious it is. By this logic, the universe itself might be a conscious entity, experiencing itself through countless local perspectives. So we return again to the question, what is reality? Is it a field of particles obeying physical laws? A projection of information from a distant boundary? A dream inside a brain? A simulation run by higher intelligence? Or is it a stream of experience unfolding in the awareness of consciousness? There may not be a single answer. Reality might be layered, physical at one level, informational at another, experiential at yet another. These layers don't contradict each other, they enrich the picture. Just as light can be both a wave and a particle, reality may be both material and mental, objective and subjective, mathematical and mysterious. The more we understand, the more we realize how much we don't know. Every step toward clarity reveals new dimensions of uncertainty. But in that uncertainty lies wonder. And perhaps that's part of what makes reality so compelling. It's not just a set of facts to be catalogued, but a living question we participate in, moment by moment, breath by breath, thought by thought. You are not simply observing reality, you are embedded in it, entangled with it, shaping and shaped by it in ways you may never fully understand. And yet, here you are, listening, thinking, being. And that too is real. As we move deeper into the nature of reality, it becomes clear that any definition must take into account the perceiver, the conscious observer. We often take for granted that reality is something out there, a world of objects and events existing independently of us. But what happens when we remove the observer from the equation? Can a world be said to exist at all if there is no one to experience it? To investigate this, consider the classic philosophical thought experiment. If a tree falls in a forest and no one is around to hear it, does it make a sound? At first glance, the answer seems obvious. Of course it does. But sound isn't simply a vibration of air molecules. Sound is the experience created when those vibrations are interpreted by a brain. Without ears to detect and a mind to process the signal, the falling tree produces vibrations, yes, but no sound as we experience it. This example highlights the essential distinction between the physical event and the conscious interpretation of that event. Reality, then, may not be separable from consciousness. This leads us to a branch of philosophy known as phenomenology, which studies structures of experience. One of its central claims is that we do not access the world directly. We access it through the lens of our experience. What you call a table is not just a piece of wood, but a mental representation built from sight, touch, and memory. In this sense, reality is not something we observe, it is something we co-create. A fascinating consequence of this idea is that no two people live in exactly the same reality. Your experiences, memories, expectations, and emotional states all color the way you perceive the world. To a person suffering from depression, the world may appear flat, dull, and hopeless. To someone in love, everything can seem brighter, more meaningful. Both people walk through the same streets, see the same sky, and yet inhabit entirely different realities. Even your sense of self, the you at the center of your experience, is more fluid than it seems. Neuroscience shows that the brain constructs a sense of continuity from moment to moment, weaving memories, intentions, and perceptions into a story. This story gives you the feeling of being a single, unified self moving through time. But this self is not fixed. It shifts depending on context, mood, and brain chemistry. In conditions like dissociative identity disorder or during deep meditation, people can experience radically different senses of identity. If your sense of self can change, and if your perception of the world is shaped by that self, then what does it mean to say that anything is truly objective? Now let's return to physics for a moment. One of the most mysterious aspects of quantum mechanics is entanglement. When two particles become entangled, their states are linked in such a way that measuring one immediately determines the state of the other, even if they are light years apart. This has been experimentally confirmed. Somehow, information seems to travel instantaneously, defying the speed limit of light. This phenomena led Einstein to call it spooky action at a distance. What makes entanglement so strange is that it challenges our understanding of separateness. If particles separated by vast distances can affect each other instantly, then space as we understand it might not be fundamental. It could be an emergent property of deeper, non-local connections. In such a framework, what appears to be here and there may only be different perspectives on the same underlying information. This interconnectedness hints at a deeper unity beneath the apparent fragmentation of the world. Some theorists have proposed that consciousness itself may be a non-local phenomenon, something that transcends the boundaries of brain and body. While this remains speculative, it resonates with certain experiences people report during altered states of consciousness, such as near-death experiences, deep meditation, or psychedelic journeys. In these states, individuals often describe a feeling of merging with the universe, a dissolution of the ego, and a direct encounter with what they perceive as ultimate reality. These experiences are intensely vivid and deeply meaningful, even if they cannot be objectively verified. Skeptics argue that these are just brain states, the result of chemical imbalances or oxygen deprivation. But others suggest that the brain might function more like a filter than a generator, a receiver of consciousness rather than its sole source. This idea, once fringe, is gaining attention in some circles. If the brain filters a broader consciousness, then our everyday awareness may be only a sliver of a much larger reality, one that is usually hidden from view. Let's pause to consider time again. Earlier we looked at how relativity reveals time to be flexible and observer-dependent. But there are deeper puzzles. For instance, why does time seem to flow in only one direction? The laws of physics are symmetric. If you reverse time in most equations, they would still work. And yet our experience is asymmetrical. We remember the past, not the future. We age in one direction. Entropy increases. What accounts for this arrow of time? One possibility is that the arrow of time is a result of thermodynamics. The second law of thermodynamics states that entropy, a measure of disorder, tends to increase in a closed system. This gives us a direction from low entropy to high. The early universe had very low entropy. Over time, stars formed, galaxies spun, and complexity increased. But as entropy continues to rise, systems break down, energy spreads out, and order dissolves. Our experience of time may simply be our consciousness moving through this thermodynamic process. But this doesn't fully explain the mystery. Why was the early universe in such a low entropy state to begin with? Some physicists argue this was just a lucky break, a cosmic coincidence. Others suspect that time itself is emergent. In this view, time is not a fundamental ingredient of the universe, but a construct that arises from relationships between changing states. In a timeless reality, change is not something that happens in time. Change is what creates the illusion of time. Now imagine a universe where time doesn't exist at all. Every moment, past, present, future, exists simultaneously, like frames on a reel of film. Your sense of movement through time is just the conscious scanning of one frame after another. In this scenario, the future is already real, just as the past is. This raises profound questions about free will. If the future already exists, are your choices predetermined? Or is your awareness simply flowing through a landscape of possibilities, choosing paths that were already mapped? One way to resolve this is through the concept of the multiverse. If all possible futures exist in branching timelines, then you are not confined to a single path. Each decision spawns a new universe, a new version of reality. In this way, free will and determinism may coexist. You are both an actor following a script and an explorer choosing your role. Of course, most people don't experience reality this way. For us, reality is a continuous stream. Waking up, going to work, eating, sleeping. But even this ordinary experience is filled with extraordinary complexity. Consider your sense of the present moment. Neuroscience shows that the brain takes about 80 milliseconds to process visual information, meaning your perception is always slightly behind real time. To compensate, the brain anticipates, smooths out, and fills in gaps. Your present is not truly now. It's a best guess stitched together from fragments of incoming data. Even your memory is not a fixed record, but a reconstructive process. Each time you remember something, your brain reassembles the memory, slightly altering it in the process. Over time, memories shift and blur. This means your past is not stable. Your experience of who you were is a narrative constantly rewritten. If your past is fluid and your present is constructed, what anchors you to reality at all? Perhaps the answer is not in what is experienced, but in the act of experiencing. Consciousness may be the one constant. Through it, all sensations, thoughts, and perceptions arise. Whether those experiences are real in an objective sense may be less important than the fact that they are happening at all. You experience, therefore, something is. This brings us to a powerful philosophical position known as neutral monism. It proposes that reality consists of a single kind of stuff, neither physical nor mental, but something more fundamental that gives rise to both. From this substrate, mind and matter emerge as different expressions of the same underlying essence. In this view, the traditional divide between subject and object, between observer and observed, dissolves. Reality is not split, it is whole. We are left then with a picture of reality that is participatory, relational, and perhaps unknowable in its entirety. We may never see the thing in itself, as Kant called it, the true nature of reality beyond our perceptions. But in each moment of awareness, we touch something profound, a mystery unfolding through sensation, thought, and presence. And so reality remains an open question, not because we haven't looked hard enough, but because it may be the kind of thing that cannot be captured from the outside. To know reality may not mean observing it, but being it. In continuing our journey through the question of what reality is, we arrive at an even stranger frontier: the mathematical structure of the universe. Some physicists and philosophers propose that reality is mathematics, not just that it follows mathematical laws, but that it is itself a mathematical object. If true, this would mean that everything we perceive, matter, energy, consciousness, space, and time, are manifestations of underlying mathematical relationships. It sounds abstract, but the implications are profound. Max Tegmark, a physicist at MIT, has advanced a provocative idea known as the mathematical universe hypothesis. According to Tegmark, every structure that exists mathematically also exists physically. This means that our universe isn't just described by math, it literally is math. In other words, the reality we live in is a set of mathematical relations being experienced from the inside. To see why this might make sense, consider how physics works. All of our successful theories, classical mechanics, quantum field theory, general relativity, are built from equations. These equations don't merely approximate nature, they describe it with astonishing precision. The orbit of planets, the bending of light near stars, the behavior of electrons, all of it unfolds according to precise mathematical rules. Why should the universe be so elegantly ordered? Why does math, a human invention, align so perfectly with physical reality? Perhaps math isn't invented, but discovered. Maybe it's not a language we apply to reality, but the fundamental structure from which reality emerges. If atoms and forces follow strict patterns, and if these patterns are governed by mathematical relationships, then perhaps the universe is not a thing, but a pattern. In this view, everything that exists is simply a solution to a vast equation. And if the universe is a mathematical structure, then many other structures are possible. Just as many different equations can exist. This leads naturally to the idea of the level 4 multiverse, in which every possible mathematical structure corresponds to a parallel universe. Ours is just one of countless realities, each with its own internal consistency, its own version of physics, logic, and time. This notion is hard to wrap the mind around, but it's consistent with how mathematics works. There are an infinite number of mathematical structures. If each one is as real as our own, then reality is not a single universe, but an infinite ensemble. And somewhere within this ensemble, every possible version of you exists. Every decision you didn't make, every life you didn't live. It's a dizzying idea. But let's bring it back to something concrete. Think about symmetry. In physics, symmetry is a guiding principle. It describes situations where certain properties remain unchanged under transformation, like rotating a sphere or flipping a shape. The laws of physics themselves are symmetrical in many ways. They work the same today as they did yesterday. They function the same here as they do billions of light years away. These symmetries constrain what kinds of particles can exist and how they interact. What's remarkable is that when a symmetry is broken, new properties emerge. This is how forces like electromagnetism and the strong nuclear force are thought to have arisen in the early universe. The breaking of symmetry creates distinction, structure, and complexity. It may be how our entire reality unfolded from a singular state of simplicity. From perfect symmetry came space, time, particles, and the vast complexity we now inhabit. This process of simplicity giving rise to complexity through symmetry breaking is one of the great organizing principles of nature. It's how snowflakes form from water, how galaxies coalesce from hydrogen, and how consciousness emerges from neural networks. At every scale, reality is patterned. But beneath those patterns lies something even more basic: relationships. Whether it's the orbit of a planet, the connection between neurons, or the attraction between particles, reality is made of interactions. If interactions are primary, then perhaps things, objects, particles, even selves, are secondary. Maybe what we call things are simply stable patterns of interaction, like eddies in a stream. They persist for a while, then dissipate. You are not a fixed entity, but a process, a dynamic interplay of matter, energy, and information, constantly changing, never exactly the same from one moment to the next. This idea is supported by what we know of biology. The atoms in your body are constantly being replaced. The cells in your skin regenerate. Your memories evolve. Yet something persists. That persistence is not a static thing, but a continuity of pattern. Your reality is not defined by substance, but by structure. Now consider virtual particles. Fluctuations in quantum fields that momentarily pop into existence and then disappear. They're not observable in the traditional sense, but their effects are measurable. They play a role in the forces between particles, the structure of empty space, and even the expansion of the universe. This suggests that nothingness is not empty. Even the vacuum is teeming with potentiality. Fields interacting, virtual particles emerging and vanishing. So perhaps reality is less like a fixed stage and more like a seething sea of possibility. Out of this sea, patterns emerge. Those patterns become particles, atoms, molecules, and eventually stars, planets, and minds. What we call reality is the surface tension of this deeper ocean of possibility. Let's shift now to the concept of emergence. In complex systems, new properties arise that cannot be predicted from the behavior of the parts alone. A single neuron can't think, but a network of billions of neurons can create thought, memory, emotion. These emergent properties are not illusory. They are real, but they arise only at higher levels of organization. In the same way, your sense of self is an emergent property. It doesn't exist in a single molecule or gene. It arises from the interaction of countless subsystems: sensory processing, memory, attention, language. The I that you feel is the collective output of this orchestra. But no conductor is required. It is self-organizing. This principle applies to societies, ecosystems, and perhaps the universe itself. Maybe consciousness is an emergent property not only of brains, but of the universe as a whole. Just as water emerges from hydrogen and oxygen, just as weather emerges from air and heat, perhaps awareness emerges from the totality of the cosmos observing itself. If so, then we return again to the idea that reality and consciousness are intertwined. Not in a mystical sense, but in a deeply structural one. The universe may not be a passive backdrop, but an active participant in its own unfolding. And your consciousness is a local expression of that participation, a way for the universe to know itself. Now consider identity. What defines you? Your body, your memories, your name, These are all changeable. You could lose your memory, change your appearance, and still feel like yourself. Why? Because identity is not static, it's a continuity of experience. It's not a fixed point, but a trajectory through time and space, shaped by causes and conditions. Buddhist philosophy speaks of the self as a bundle of processes: feelings, perceptions, impulses, and awareness. No core essence, just a flow. Western science is beginning to echo this view. Neuroscience can't locate a single self in the brain. There's no command center. Instead, consciousness seems to arise from the integration of many competing modules, each handling different tasks, each vying for attention. The self is a narrative woven from competing inputs. This challenges our everyday assumptions, but it also opens up new possibilities. If the self is a story, it can be revised. If identity is fluid, it can evolve. You are not a fixed observer of reality. You are part of it, shaped by it, shaping it in return. So what is reality? It is a pattern of patterns, a network of relationships, a dance of information and energy arising and dissolving. It is not a static thing, but a becoming, a process of emergence. And within it, you are not merely a spectator, you are the movement itself. Everything you experience, sound, sight, thought, emotion, is a doorway into that unfolding. And while the mechanisms may be mysterious, the experience is immediate. It is happening now, in this very moment, in the awareness that is listening, reflecting, questioning. Whatever reality ultimately is, whether mathematical structure, conscious experience, or something beyond both, it is not separate from you. You are inside it, and it is inside you. Let us now explore another profound dimension of reality, the experience of now. The present moment feels uniquely real. The past is memory, the future is imagination, but now is something we seem to actually inhabit. But what is this now, really? And why does it feel so central to our sense of reality? Physicists have long argued that now doesn't exist in any objective sense. According to Einstein's theory of relativity, simultaneity is relative. There is no universal present. Two observers moving at different speeds or located in different gravitational fields will not agree on which events happen at the same time. The consequence of this is startling. The idea of a single, shared now across the universe is an illusion. Every point in space has its own timeline, and what is now for you might be in the past or future for someone else. So why does the present feel so real? Some scientists propose that the sensation of now is a product of consciousness, a mental construct that allows organisms to coordinate perception, decision-making, and memory. The brain integrates sensory information and organizes it into a narrative that includes a continuously updating present. But the brain operates with delays. Light takes time to reach your eyes. Electrical signals move through your nerves at limited speeds. And yet you don't experience lag. You experience a smooth continuity. That's because the brain is always predicting, interpolating, smoothing. Your now is a reconstruction. In this sense, the present isn't a moment frozen in time, it's a process. Your sense of now is like a spotlight moving through a mental map of the world, drawing attention to relevant details, discarding others. You're not living in the present as it happens. You're experiencing an edited, simulated version of it, a present that already happened a fraction of a second ago. If the present is an illusion, what does that mean for our experience of time? Many philosophers argue that the flow of time, the feeling that moments come and go, is a psychological phenomenon, not a physical one. The equations of physics are time symmetric. They don't prefer forward or backward. They describe a static four-dimensional space-time block in which every event simply is. There's no need for time to move. Time doesn't flow. We do. But even if time is an illusion, it is a useful one. Our sense of past, present, and future allows us to function, to plan, to remember, to grow. The illusion is part of our cognitive toolkit. It helps us survive. Still, this raises a deep question. If our experience of time is a construction, how much else about our reality is similarly constructed? Take color, for example. There's no such thing as red or blue in the external world. These colors are how your brain interprets different wavelengths of light. Outside of your perception, they are just electromagnetic frequencies. Sound is the same. It's not music or noise in itself, it's pressure waves in air. The qualities, sweet, sharp, soft, frightening, exist only in your consciousness. Much of what we call reality is sensory translation. Even objects aren't as solid or stable as they appear. On the atomic scale, they're made mostly of empty space. The hardness of a rock, the smoothness of glass, these are not intrinsic properties of matter, but emergent qualities based on how our nervous systems interact with atomic forces. What you call a chair is a cloud of particles bound by fields, experienced as stable through sensory consistency and social agreement. This constructed nature of experience leads to an important insight. We don't perceive reality directly. We perceive an interface. Cognitive scientist Donald Hoffman likens it to a desktop computer screen. You see icons, a folder, a file, a trash can. But those icons aren't the actual circuits and magnetic fields making things happen. They're a simplified interface that lets you interact with the deeper system. In the same way, space, time, and physical objects may be the icons of consciousness, useful abstractions for interacting with a deeper, inaccessible reality. Now let's entertain a radical possibility, that space and time themselves are not fundamental features of reality, but emergent from something more basic. Recent theories in quantum gravity and string theory suggest that space-time may arise from more primitive entities, such as entangled quantum states or informational networks. In these models, what we call space is a derived concept, not a starting point. It emerges from correlations between data, not from a pre-existing grid. One theory, called entropic gravity, proposes that gravity is not a fundamental force, but a statistical effect, a result of information entropy in microscopic systems. In other words, gravity may not be a thing that pulls on masses, but an emergent consequence of how information organizes itself. This turns the traditional view inside out. Instead of matter shaping space-time, perhaps space-time and its geometry emerge from the flow of information. What does it mean to say that the universe is fundamentally information? It means that the most basic description of the world is not in terms of things, but in terms of relationships, correlations, measurements, interactions. These are mathematical, logical, and dynamic, and from them everything else arises. Particles, fields, forces, time, space, and perhaps even consciousness. At this point, we must consider the idea that reality may be computational. Just as a computer simulates environments and processes by executing instructions, the universe might operate as a vast computation unfolding across a cosmic substrate. This doesn't mean there's a literal computer somewhere, but that the structure of reality behaves as if it's executing a program. Laws of physics may be algorithms, particles may be data packets, interactions may be logical gates, and consciousness may be a recursive process within that system. This leads naturally to simulation theory. If reality is information-based and computational, and if it is possible to simulate consciousness in a sophisticated enough system, then the question arises, are we living in a simulated universe? Philosopher Nick Bostrom has argued that if any civilization becomes advanced enough to simulate conscious beings, and chooses to do so, then the number of simulated minds would vastly exceed the number of original biological minds. Statistically, it becomes likely that we are among the simulated. Skeptics dismiss this idea as science fiction, but it cannot be ruled out purely on physical grounds. In fact, some physicists have proposed potential signatures of simulation, such as limits to computational precision or specific artifacts in cosmic rays. Others argue that the universe behaves like a quantum computer. If the laws of nature reflect informational limits, we might be seeing the resolution boundaries of an immense simulation. Of course, even if we are in a simulation, it doesn't make our experience any less real. After all, reality is what we interact with. Whether it's generated by a natural process, a divine intelligence, or an advanced civilization, your experiences still feel valid. The taste of food, the pain of loss, the beauty of the stars, these remain meaningful. If anything, simulation theory forces us to rethink what real means. Maybe reality isn't about origin, but coherence. If your experience forms a coherent world governed by consistent rules, then perhaps that is reality enough. Let's pause for a moment and reflect on your own experience. You are listening to these words. You are hearing sound, forming ideas, imagining concepts. All of this is happening within your field of awareness. No matter how vast the universe is, no matter how complex the theories become, your consciousness is the foundation of your reality. Everything you know, everything you believe, everything you remember flows through that portal. This doesn't mean that the world is a figment of your imagination, but it does mean that reality is something you participate in. It is not delivered to you, it is constructed with you. In every moment, your brain, your body, and your environment are co-creating a world, and that world is not separate from you. You are embedded in it. You are made of it. If the universe is a grand computation, then you are a subroutine, a process within the process. If the universe is a dream, you are the dreamer and the dreamed. If the universe is information, you are one of its expressions. And if the universe is consciousness becoming aware of itself, then your awareness is part of that awakening. So what is reality? It is the unfolding of pattern into presence, the crystallization of possibility into experience. It is not merely the stage on which life plays out. It is the play, the actors, the audience, and the awareness that holds it all. And through your presence in this moment, you are touching that mystery directly. We've explored how perception, time, and consciousness shape our understanding of reality. But to go deeper, we must now examine the fundamental building blocks of the universe. What is the world made of? What lies beneath the surface of what we see, touch, and measure? For centuries, the answer to this question was matter. Atoms, once considered indivisible, were thought to be the ultimate constituents of the physical world. But as science progressed, we discovered that atoms themselves are made of even smaller particles: protons, neutrons, and electrons. And even these are not fundamental. Protons and neutrons are composed of quarks held together by the strong nuclear force, and electrons are part of a family called leptons. These particles make up the standard model of particle physics, which describes the known elementary particles and their interactions. It includes quarks, leptons, and force-carrying particles like photons and gluons. The Higgs boson, discovered in 2012, gives particles mass through interaction with the Higgs field. This framework has been immensely successful at explaining particle interactions in experiments, but it leaves many deep questions unanswered. For instance, gravity isn't included in the standard model, nor is dark matter, which seems to make up most of the mass in the universe. And we still don't understand the nature of dark energy, the mysterious force causing the expansion of the universe to accelerate. What's more, the standard model doesn't explain why the fundamental constants of nature are what they are. Why do particles have the masses they do? Why are the forces balanced in the precise way that allows stars, planets, and life to exist? This has led physicists to search for deeper theories, more fundamental descriptions of reality that unify what we know. One approach is string theory, which proposes that all particles are not points, but tiny vibrating strings. These strings can vibrate in different modes, producing different particles depending on their frequency. It's a beautiful idea because it suggests that everything, matter, energy, space, time, is a manifestation of a single kind of entity behaving in different ways. String theory also requires additional dimensions, more than the four we experience. These extra dimensions are thought to be curled up or compactified at scales too small to detect. If real, they could explain many of the strange features of particle physics and potentially unify all forces, including gravity. However, string theory is difficult to test experimentally. It operates at energy scales far beyond what we can currently reach. Critics argue that it makes too many predictions to be falsifiable. Others maintain that it offers our best hope at a theory of everything, a single framework from which all physical laws emerge. Alongside string theory, there's loop quantum gravity, another attempt to unify general relativity and quantum mechanics. This theory suggests that space itself is quantized, made of tiny discrete loops that form a kind of quantum fabric. Instead of being continuous, space-time is composed of indivisible units, like the pixels on a screen. At large scales, this fabric appears smooth, just as a digital image can look smooth from a distance. But at the smallest scales, it is granular. These theories challenge the classical idea that space and time are a continuous stage. If space-time is made of quantum bits, then geometry itself is a product of information. That means reality isn't just made of stuff, it's made of structure, relationships, patterns. Now consider this. What if the most fundamental layer of reality isn't made of particles or fields at all, but of relations between entities? This idea lies at the heart of many quantum theories. In quantum mechanics, particles do not have definite positions or properties until they are measured. Instead, they exist in superpositions, probability clouds of potential states. Measurement doesn't just observe the system, it defines it. Reality is participatory. This participatory nature is most famously illustrated by the double-slit experiment. When a particle like an electron passes through two slits, it creates an interference pattern, like a wave interfering with itself. But if we try to measure which slit it went through, the interference pattern disappears. The act of observation changes the outcome. The system behaves like a particle or a wave depending on how we observe it. So which is it really? The answer seems to be, it is neither until you ask. Some interpretations of quantum mechanics take this further. The relational interpretation suggests that the properties of particles don't exist in isolation. They exist only in relation to other particles or to observers. There is no absolute state of a system, only interactions. In this view, reality is not a fixed tapestry, but a dynamic network of events and relationships. Things are what they do, not what they are. This challenges our intuition. We're used to thinking of objects as having inherent properties, existing independently, but quantum mechanics seems to imply that independence is an illusion. Everything is entangled, deeply connected, even across vast distances. Experiments have shown that two particles, once entangled, can influence each other instantly, no matter how far apart they are. Einstein called this spooky action at a distance, but it has been verified again and again. How can this be? Some physicists argue that space itself is not fundamental. Instead, it's an emergent property of entanglement. The geometry of space-time, the distance between things, could arise from the degree of quantum correlation between them. Two particles might be close not because of location in space, but because of information shared. Distance becomes a matter of connectivity. This reframes everything. Reality is no longer about where things are, but how they are related. The structure of reality is determined by the web of entanglement, and space-time emerges from that web. Even time might be a side effect of how information flows between entangled systems. Consider the it from bit idea proposed by physicist John Wheeler. He argued that every physical thing, every it, derives its meaning from bits of information. Reality is fundamentally digital, made of yes-no questions, measurements, binary distinctions. From this informational substrate, the entire universe emerges. If this is true, then atoms, forces, and even space-time are high-level manifestations. They are the surface layer of something deeper, a sea of computation, constantly processing, evolving, calculating its next state. Not a computer in the ordinary sense, but a process that functions computationally, where the rules are not coded but discovered. This also forces us to reconsider what laws of physics are. Traditionally, we think of laws as eternal truths, written into the fabric of the universe. But what if laws evolve? Some scientists have proposed that the universe is not governed by fixed equations, but by self-organizing principles that emerge from the system's behavior. In this view, the rules of reality might be more like habits, stable patterns that develop over time, but which can shift under the right conditions. If physical law is emergent, then so is order itself. The regularities we observe may be temporary, the result of deeper processes we have yet to understand. Even the constants of nature, like the speed of light or the strength of gravity, might not be constants at all, but dynamic features of a developing cosmos. Let's take a moment to reflect on the implications. The world you see around you, the solidity of matter, the ticking of clocks, the stretching of distances, is built from invisible patterns, probabilistic events, and relational structures. Reality is not a thing, but a process, not a place, but a pattern. And you, as a conscious being, are part of that pattern, woven into the tapestry by your perceptions, your interactions, your presence. So what is reality? It is not a static backdrop. It is not a fixed stage on which things unfold. It is the unfolding itself. It is change, relation, emergence. It is not something you stand apart from. It is something you're immersed in, something you participate in, something that becomes real through your very act of noticing it. And the deeper we look, the more we find not particles, but possibilities, not places, but perspectives, not absolutes, but awareness. The deeper we explore the nature of reality, the more we encounter the idea that what is most real may not be material at all, but informational. This leads us into one of the most profound and controversial questions of modern science and philosophy. Is the universe a simulation? The simulation hypothesis suggests that everything we experience, our thoughts, bodies, planet, and even the cosmos itself, might be part of an artificial environment generated by an advanced intelligence. At first glance, this may sound like science fiction, but as computing power increases and our understanding of information deepens, this question has gained serious attention among physicists, philosophers, and technologists. The idea traces back to philosophical roots. In the 17th century, René Descartes proposed a thought experiment where a powerful deceiver could create an illusion so convincing that one couldn't tell it from reality. Fast forward to the 21st century, and the deceiver could be a computer running a vast simulation filled with conscious agents who believe they are real. The modern version of the argument was popularized by philosopher Nick Bostrom. He suggested that at least one of the following must be true. 1. Human civilizations never reach a level of technological maturity where they can run realistic ancestor simulations. 2. Such civilizations choose not to run simulations. Or 3. We are almost certainly living in a simulation. The logic is deceptively simple. If it's possible to simulate conscious beings, and if future civilizations can run billions of such simulations, then simulated minds would vastly outnumber biological ones. Statistically, you are more likely to be one of the simulated minds than one of the rare originals. Whether or not this is literally true, the hypothesis forces us to reconsider what it means for something to be real. If you lived in a perfectly convincing simulation with consistent laws of physics and internal consciousness, would it make any difference? Could you ever even know? Some scientists argue that we might detect signs of a simulated universe by finding digital artifacts in the fabric of physics, like limitations in resolution or anomalies in the behavior of quantum particles. Others suggest that the simulation theory is unfalsifiable and thus not scientifically useful. But even if it turns out to be incorrect, the underlying insight remains valuable. Information and computation may be more fundamental than matter. The universe as we know it behaves like a massive processor. It evolves from one state to the next by following rules, often described by differential equations or probabilistic models. Whether it's a literal simulation or not, the cosmos might operate like a vast information processing system. This idea has found support in several corners of physics. Quantum mechanics, for instance, can be described as a theory about information, about what can be known and how knowledge changes when measurements are made. In quantum field theory, particles are seen as excitations in fields, and these excitations carry information across space-time. Even gravity, in some formulations, can be derived from thermodynamic principles, suggesting that space-time geometry might emerge from the statistical behavior of microscopic information bits. One striking example comes from the study of black holes. According to general relativity, black holes are regions where gravity is so strong that nothing can escape, not even light. But quantum mechanics tells us that black holes radiate energy over time through a process called Hawking radiation. This creates a paradox. If information about the matter that falls into a black hole is lost, it violates the basic principle of quantum theory, that information cannot be destroyed. To resolve this, physicists proposed that information is somehow encoded on the event horizon, the boundary of the black hole, and slowly released as radiation. This led to the holographic principle, the idea that everything inside a volume of space can be described by information encoded on its boundary, like a hologram. If this principle is true not just for black holes, but for the entire universe, then our three-dimensional reality might be a projection from a two-dimensional surface. The universe would be fundamentally holographic, a 3D illusion generated by lower dimensional data. This may sound abstract, but it's grounded in concrete math. The ADS, while a CFT correspondence, a breakthrough in string theory, shows how a gravitational theory in one space can be equivalent to a quantum field theory on its boundary. This duality suggests that gravity and space-time itself can emerge from quantum entanglement and information flow. So what does this mean for us? It suggests that reality is not what it seems, that depth, distance, and even time might be emergent properties, not fundamental ingredients. It also suggests that consciousness, far from being an afterthought of evolution, might play a central role in the way the universe generates appearances. Let's shift our attention to perception. The world you experience is not a direct reading of the external environment. It is a reconstruction, an internal model your brain creates using limited sensory data. Light bounces off objects, enters your eyes, and stimulates photoreceptors. Electrical signals travel through neural pathways, are interpreted by visual cortices, and presented to you as shapes, colors, and motion. Sound is pressure waves turned into vibration, then interpreted as music or language. Taste and smell are molecular signatures translated into memory and emotion. Everything you perceive is an internal simulation. Your brain doesn't give you reality, it gives you a useful version of it. It filters, enhances, and simplifies, turning a torrent of data into something coherent. And this simulation isn't just passive, it's predictive. Your brain constantly guesses what's next, then adjusts when it's wrong. You don't see the world as it is, you see it as you expect it to be. This predictive model extends beyond perception into thought, emotion, and identity. Who you think you are, yourself, is also a model. A constructed narrative updated by experience, shaped by memory, emotion, and language. But the model is not the thing. The self is not an object, it's an activity, an ongoing story, a process, not a substance. This invites us to reimagine the distinction between reality and illusion. We often think of illusions as mistakes, as errors in our perception. But if everything we perceive is mediated by our brain, then all perception is a kind of illusion. A useful, adaptive one, but a fiction nonetheless. Does this mean nothing is real? Not at all. It means reality is layered. At one level we have the sensory model, the world of sights and sounds, colours and textures. At a deeper level we have the physical structure, the particles and fields, the quantum probabilities and entanglements. And at the deepest level, perhaps, we have pure information, relationships, interactions, possibilities. The question becomes, which layer is most fundamental? Is it the particles, the patterns, or the process itself? If information is the root, then existence may be less like a thing and more like a computation. A ceaseless unfolding of relations governed by abstract logic. We are a part of this unfolding. Our thoughts, choices, and consciousness may influence how reality emerges, not because we change the world with our minds, but because our participation is baked into the system. We are not external observers, we are entangled participants. Even the act of asking, "What is reality?" is a recursive loop. You are reality, inquiring about itself, a localized expression of the cosmos, reflecting on its own patterns. The boundary between subject and object dissolves, and all that remains is the flow of awareness. This leads some to suggest that reality is fundamentally mental, not in a solipsistic way, but in the sense that consciousness might be a primary feature of the universe. Panpsychism, for instance, proposes that consciousness is not limited to humans or animals, but is a fundamental aspect of all matter. Even the simplest particles may have proto-conscious properties. These do not resemble our awareness, but they may contribute to the emergence of mind when arranged in complex systems. This is speculative, of course, but it reflects a growing openness to bridging the gap between mind and matter, not by reducing one to the other, but by recognizing them as different aspects of the same process. Reality, in this view, is a unity that expresses itself in both experience and structure, in both perception and pattern. You are not separate from this. You are not a thing in a universe. You are the universe, aware of itself through the lens of a particular experience. Your thoughts are waves on the ocean of being. Your awareness is a local flare of a cosmic intelligence. You are reality, reflecting back on itself in wonder. To understand what reality is, we have to investigate one of the most confounding aspects of it: time. Most of us assume time flows forward, from past to future. We imagine it as a river, constantly moving, carrying everything along with it. But when we peer into the foundations of physics, that familiar river begins to dissolve. Time, as we perceive it, may not be fundamental at all. Let's start with a surprising fact. The equations that govern the basic laws of physics don't actually require time to flow. They work just as well forward as they do backward. Whether it's Newton's laws, Einstein's relativity, or the equations of quantum mechanics, they are time symmetric. Nothing in the math says time must move in only one direction. So why does time feel like it flows? Why do we remember the past and not the future? Why does a glass shatter but never reassemble? The answer lies in entropy. Entropy is a measure of disorder. The second law of thermodynamics tells us that in a closed system, entropy tends to increase. Over time, things become more disordered. Ice melts, coffee cools, stars burn out. This increase in entropy gives us the arrow of time, a direction from past to future. But this arrow might not be built into the universe. It could simply be the result of initial conditions. If the universe began in a state of extremely low entropy, highly ordered, then entropy had nowhere to go but up. That's why we remember the past. It was more ordered. That's why eggs break but don't unbreak. The chances of all particles spontaneously returning to their former state is astronomically small. Not impossible, just overwhelmingly unlikely. But what if time isn't even fundamental? Some physicists argue that time is not a basic ingredient of the cosmos, but an emergent property, something that arises only under specific conditions like temperature or pressure. According to this view, time might be a kind of illusion, a useful one, but not ultimately real. One way this idea surfaces is in quantum gravity, attempts to unify quantum mechanics with general relativity. In loop quantum gravity, for instance, time disappears from the equations entirely. The fundamental structures are not particles moving through time, but networks of relationships, geometry itself in flux, without a universal ticking clock. If time can emerge from something deeper, then reality is not a sequence of events, but a static whole, a timeless tapestry. This is the idea behind the block universe, a view supported by Einstein's theory of relativity. In the block universe, past, present, and future all exist simultaneously. Time doesn't flow, it just is. Your birth, this very moment, and your future are all equally real, laid out in a four-dimensional space-time continuum. From this perspective, our experience of time's passage is an illusion, a trick of consciousness moving through a frozen structure. This idea may be hard to grasp. After all, we feel time passing. But consider this. Our brains process one slice of space-time at a time. Like a needle reading a record, we scan across the block universe, creating the illusion of motion. The music of time is not in the notes themselves, but in the sequence we experience them. Now, zoom out. Imagine seeing all moments at once, the entire history of the universe from beginning to end as a single entity. From that godlike view, time has no direction. It simply is. All events are eternal, fixed in the structure of space-time. Does this mean free will is an illusion, that everything is predetermined? Not necessarily. Determinism and timelessness are not the same. Even in a block universe, events can be contingent. Your choices might still be part of the fabric, but they are real choices. Just because all pages of a book already exist, doesn't mean the story isn't meaningful. Let's return to the quantum realm. Here, things get even stranger. In quantum mechanics, the future is not fixed until it is observed. Particles exist in multiple states simultaneously, a superposition, until a measurement forces them into one state. This is the infamous collapse of the wave function. The act of observation doesn't just reveal reality, it seems to help create it. Some interpretations, like the Copenhagen interpretation, suggest that the observer plays a central role in determining outcomes. Others, like the many worlds interpretation, argue that all possible outcomes occur, each in a different branch of the universe. In that case, there is no collapse, just branching. These quantum puzzles challenge our intuition. In some experiments, particles seem to decide how to behave after they've already been measured, suggesting that the future can influence the past. This has led to theories of retrocausality, where cause and effect can loop in both directions. While these ideas are controversial, they remind us that our assumptions about time and reality are deeply incomplete. Could our perception of a flowing present be a feature of consciousness, not the universe? Neuroscience tells us that the brain doesn't experience events in real time. It integrates information over fractions of a second, smoothing out discontinuities and creating a unified now. What we perceive as the present moment is a constructed narrative, lagging just behind actual events. It's like a movie stitched together from individual frames. This brings us to a deeper question. Is time something out there or something in here? If time is a mental construct, then our experience of reality is shaped not by the world itself, but by the brain's interpretation of change. We don't perceive the world directly, we perceive models of it, updated over time. In this sense, time is less like a dimension and more like a framework for organizing experience. Some traditions in philosophy and spirituality have long intuited this. In various schools of Buddhism, for instance, time is seen as an illusion, Maya, a veil that conceals the true, timeless nature of reality. Enlightenment is not a state of acquiring knowledge, but of seeing through the illusion of time and self. Interestingly, physics is arriving at similar conclusions from a different direction. The more we look for a fundamental now in the equations, the more it slips away. There is no privileged moment, no universal clock, no master timeline. Time, like space, may be relative, dependent on the observer. If there is no absolute time, then what anchors reality? Some physicists propose that what's fundamental is not time, but change. Carlo Rovelli, a prominent physicist, argues that instead of thinking about things evolving in time, we should think of events as relations. Reality is made of processes, not objects. What exists are interactions, not things enduring through time, but temporary patterns emerging from constant flux. From this view, the universe is not a stage on which things happen. The universe is the happening. You are not a fixed self moving through time. You are a changing process, part of a larger web of change. Your memories, identity, and future hopes are all woven into this dynamic tapestry. This makes time less of a ticking metronome and more of a network, a constellation of connections, causality, and correlation. It's not that events are ordered along a single line, but that they influence each other in patterns. Time emerges from this structure, the way music emerges from notes and rhythm. Now consider this. If time is not fundamental, then perhaps nothing really happens in the deepest sense. The universe just is, a vast structure of possibility, already complete. We experience events because we are embedded in a portion of this structure, like characters in a story, unaware of the author. But what a story it is, one filled with movement, conflict, joy, loss, discovery, and transformation. Whether time is real or not, our experience of it shapes our existence. It gives meaning to change, to growth, to love and loss. It gives us seasons, lifetimes, histories, and dreams of the future. And yet, beneath it all, reality may be timeless. You are not simply moving through time. You are the convergence of countless threads, physical, mental, emotional, informational, all coalescing into this very moment. From a deeper perspective, you are not in time. You are time unfolding into form. In that realization, perhaps the question changes. Instead of asking what is reality, we might ask, what does it mean to experience reality? What does it mean to be an observer, a mind, a witness of this mysterious unfolding? We don't have all the answers, but perhaps that's the point. Reality is not something to be solved, but lived. And in living it, we get glimpses of something beyond words, a deeper coherence behind the chaos, a hidden order behind the appearance of randomness. And maybe, just maybe, that mystery is the most real thing of all. To explore what reality is, we must venture even deeper into the strange overlap between physics and consciousness. At the limits of our understanding, the boundary between what is out there and what is in here becomes blurry. Are we discovering reality or creating it as we observe? What role does the mind play in shaping the cosmos we think we see? Let's begin with quantum mechanics. It's one of the most successful theories in all of science, accurate to more than 10 decimal places in some experiments. But its interpretation remains one of the most unsettled areas in physics. When we observe a particle, we find it in a definite state. Here, not there. Spin up, not down. But before measurement, it exists in a state of superposition, a probability wave of all possible outcomes. So what causes the wave function to collapse into one outcome? One answer is the observer. According to the Copenhagen interpretation, it's the act of measurement that transforms the cloud of probabilities into a definite state. This doesn't necessarily mean that a conscious mind causes reality to become real, but it implies that without observation, properties like position, momentum, or spin are undefined. This leads to some unsettling possibilities. If observation is needed to bring about a specific outcome, then reality isn't fixed until it's seen. The famous double-slit experiment supports this. When particles are not observed, they behave like waves, creating interference patterns. But when we measure which slit a particle goes through, the interference disappears. It behaves like a particle instead. The very act of watching changes the outcome. Some physicists and philosophers have taken this further. What if the conscious mind doesn't just passively observe reality, but actively participates in its creation? This is the idea behind participatory realism and, more speculatively, behind the consciousness causes collapse interpretation of quantum mechanics. It's controversial, but it forces us to reconsider what we mean when we talk about observation. In quantum experiments, the measuring device is typically not a person. It's a sensor, a detector, a screen. But ultimately, the results are only known when a conscious observer reads them. So where exactly does the transition from quantum uncertainty to classical certainty occur? Is it in the detector, the computer, the brain, or consciousness itself? No one knows for sure. This ambiguity opens the door to something extraordinary, that consciousness and reality may be entangled at the most fundamental level. Let's go a step further. In some interpretations, the universe doesn't exist as a definite, concrete thing until it is observed. This idea appears in John Wheeler's participatory anthropic principle, which suggests that observers are necessary for the universe to come into being in its present form. Wheeler once said, "The universe does not exist out there, independent of all acts of observation." Taken seriously, this means that reality is not a fixed backdrop, but a co-creation between the cosmos and consciousness. This doesn't mean reality is an illusion, but it may be incomplete without a mind to perceive it. Some versions of this thinking appear in digital physics, the idea that the universe is fundamentally informational. According to this view, the basic fabric of reality is not matter or energy, but information. Bits, not atoms. Reality is computation, unfolding moment by moment. Your experience, your thoughts, your memories, your sense of being, is the output of an unimaginably complex processing of information. What's the difference between information and matter? Information needs a medium to exist, but not a specific one. A thought can be stored in a neuron, or a silicon chip, or scratched into a rock. What matters is the pattern. So in this view, you, the observer, are an informational pattern. and the universe too is a vast network of interacting information. This leads to a provocative question: could we be inside a simulation? Simulation theory, popularized by philosophers and tech entrepreneurs alike, proposes that if it's possible to simulate conscious beings in a computer, and if advanced civilizations will eventually develop that ability, then it's likely we are living in one of those simulations rather than in base reality. It sounds like science fiction, but statistically, if one civilization could run billions of simulations and only one is real, the odds tilt in favor of being simulated. Some physicists have even looked for signs, digital glitches in the cosmic background radiation, or limitations in the precision of physical constants. So far, there's no hard evidence, but the question persists. How would we even know if we were simulated? Could a mind trapped inside a simulation ever find proof of the real? Even if we aren't inside a computer simulation, reality might still be virtual in a different sense. The brain doesn't perceive the world directly. It constructs a model of it based on sensory input. When you look around, you're not seeing reality, you're seeing a neural simulation of reality. Color, sound, texture, depth. These are interpretations created in the brain. They feel real, but they are representations, not direct contact. So even if the world outside is real, your experience of it is always filtered. You're walking through a model your mind is constantly updating. This model is shaped by evolution, not to be accurate, but to be useful. Our senses evolved not to show us the truth, but to keep us alive. So what we see is not reality itself, but a convenient interface, a kind of heads-up display for survival. This concept is sometimes called the user interface theory of perception. It's like looking at icons on a desktop. What matters is not what's under the hood, but whether you can use the tools. The trash can icon isn't really a can, it's a symbol for a process. Likewise, the apple you see isn't the apple itself, but a mental model that helps you eat it. So where does this leave us? If the mind constructs its own experience of the world, and if observation plays a role in shaping what is observed, then reality is not something entirely separate from us. We are not just looking at the world, we are participating in its unfolding. This may sound mystical, but it arises naturally from physics, neuroscience, and philosophy. It doesn't mean everything is subjective. There is a shared structure, a consistency in the world that we can agree upon. But how we access that structure is always through perception, through interpretation, through consciousness. In some theories, consciousness itself may be fundamental. Integrated information theory, IET, suggests that consciousness arises from the integration of information within a system. The more interconnected and unified the information, the greater the consciousness. If true, this means consciousness is not an emergent property of the brain, but a property of certain kinds of systems. Even some very simple systems might have tiny flickers of awareness. This idea aligns with panpsychism, the view that consciousness is not unique to humans or even animals, but is a fundamental aspect of the universe, like mass or charge. In this view, every particle carries a sliver of experience, not thoughts or emotions, but something like being. The universe, then, is not dead matter animated by life, but a vast field of experience, of which you are a complex and self-aware expression. We don't yet know if these ideas are true, but they stretch our understanding of what reality could be. They force us to reconsider what we mean by objectivity, truth, and existence. They blur the line between the observer and the observed. between mind and world. So let's return to the question, what is reality? Reality might not be a static thing waiting to be discovered. It might be a dynamic interaction between structure and perception, a field of potential crystallized into experience through observation and awareness. You are not just a passive viewer, you are a node of consciousness embedded in the universe. You don't merely see reality, you participate in shaping it. Every moment of awareness, every act of attention is a ripple in the fabric of the cosmos. You are not outside the universe looking in. You are the universe looking at itself. Whether or not we are in a simulation, whether or not time is real, whether or not matter is solid, your experience is. That undeniable spark of awareness is the most immediate truth you have. In the vast mystery of existence, perhaps that is the deepest clue of all. If we accept that our perception of reality is not a direct reflection of the external world, but a sophisticated construction created by the brain, then we begin to realize that consciousness isn't just a passenger, it's part of the engine. The question of what is reality isn't just a scientific inquiry, it's personal, because to understand reality is, in a very real sense, to understand yourself. Let's reflect on what we've uncovered so far. We've seen that the particles making up the physical world aren't solid objects, but probability clouds, existing in states of uncertainty until something, perhaps observation, locks them into position. Time may not flow as it appears to us, but could be a fixed dimension in a larger, four-dimensional block of space-time. The matter we think of as solid is mostly empty space, and even that space is filled with quantum fluctuations and energetic fields. In every direction we look, the boundaries of realness become less and less stable. And at the center of this experience is the one thing you cannot deny, your own awareness. Let's talk briefly about the concept of solipsism, the philosophical idea that only your own mind can be known to exist. While it's an extreme view, it emphasizes something important. We can never truly leave our own minds. Everything we experience, from light to sound to touch, is filtered through neurons, synapses, and perception. So how do we know what's real? The answer may be that reality is not a single thing. It may be layered. Physical reality, perceived reality, shared social reality, inner emotional reality, mathematical reality. None of these are illusions. They're all real, but in different ways. A dream is not physically real, but it is experientially real. A law of physics is not tangible, but its effects are universally observed. A belief isn't an object, but it can shape behavior, alter history, and define societies. Take mathematics. Is it discovered or invented? Some argue that mathematical truths exist outside of time and space, waiting to be found. Others say we created them, useful abstractions that happen to describe the universe. But either way, they seem to touch something fundamental. The language of mathematics underpins quantum physics, relativity, and even chaos. Equations describe the motion of planets, the evolution of stars, the structure of DNA, and the behavior of particles we cannot even see. If abstract thought can mirror the universe so precisely, what does that say about the nature of the universe? Is reality inherently mathematical? Is it consciousness friendly? Or are we just good at finding patterns in noise? These questions might sound philosophical, but they are pressing issues at the frontiers of physics. Some theorists suggest that the universe may be a mathematical object, pure geometry unfolding in multidimensional space. Others argue that consciousness itself may arise from deeper laws not yet discovered that lie beyond both mind and matter. And yet, despite all these possibilities, we live in a practical world. We walk on sidewalks, drink water, talk to people. Most of the time, we don't question what's real. Reality is what we bump into. It's gravity holding you down. It's sunlight hitting your skin. It's the feeling of time moving forward, whether or not time itself is real. Our intuitions, shaped by evolution, are designed for survival, not cosmic understanding. But when we step outside of those instincts, when we look at the night sky or listen to the quiet hum of the universe, through science, we start to see reality not as fixed, but as fluid, not as obvious, but as mysterious, not as simple, but as layered and strange and beautiful. There's something profound in knowing that the atoms in your body were forged in stars, that the thoughts you're having are electrical patterns shaped by billions of years of evolution, that what you experience as the present moment is already part of the past in some distant galaxy, whose light has yet to reach us, and that the reality you inhabit is not a cold machine, but something deeply woven with awareness, chance, time, and perhaps meaning. At its deepest level, reality seems to resist simple explanation. It offers paradoxes, illusions, and recursive loops. It contains observers who change what they observe, brains that model worlds inside themselves, and a universe that behaves like a riddle whose answer includes the one asking. So where do we go from here? Some find comfort in uncertainty. Not knowing means there's more to learn, more to explore. Others feel discomfort. If reality has no solid foundation, how can we trust anything? But both reactions miss something essential. Reality may not be a fixed stage, but it is consistent. It is reliable enough for us to build rockets, send messages across oceans, and fall in love with someone we cannot see. It is stable enough for life to evolve, for stars to burn, for stories to unfold. You don't need to have all the answers to live meaningfully within it. And maybe that's the point. Perhaps the mystery is part of the design. Not to frustrate us, but to awaken us. To remind us that even in the most mundane moment, the strange hum of existence is still echoing. That behind every experience, there is still the question, what is all this? Why does it feel like anything at all? You are the questioner and the questioned, the observer and the observed, the mind peering into the universe and the universe peering back. You are made of particles older than the earth, arranged by laws more ancient than time, and animated by something that may be eternal. If we return to the beginning, to the question of what is reality, perhaps the most honest answer is, we don't know. But what we do know is extraordinary. We know we are here. We know we can wonder. We know we can look up at the stars and ask where it all came from. And maybe that ability to question, to reflect, is itself a clue. Tonight, as you let your mind wander into dreams, you're stepping into yet another version of reality. A world of imagination and symbols where the rules are different but the experience is still real. Let that be a comfort. Not everything real has to be measurable. Not everything true has to be proven. So close your eyes, let your breath slow, and remember this. Reality may be bigger than we can ever grasp, but you are part of it. Your awareness, your story, your tiny corner of the cosmos, it matters. Because reality isn't just out there, it's also right here within you. Good night from Sleep Space. Wherever you are, whatever time it is, may you find peace in the wonder.